Hello, everybody. Hope you're all doing great today. So, I have another video for you. Um, I know I said just one to two. You know, I see that they're working, so maybe I'll do it more often. I'm still not sure yet, but I am going to do a third one this week. So, let's talk about the area between two triangles. This is the next IXL assignment that you probably saw. This is FF.8. And this is very similar to what we did yesterday. Um, Let me clear this off. So, yesterday, remember we found how to find the area of a shaded region. It's like the area of a rectangle with a hole in it. So, we are going to talk about that today with triangles, but first, before we get there, I just want to talk about the formulas. So, the area of a rectangle, we've talked about this plenty. We know that this is the length times the width, and we know that we can represent the length with the letter L, and we can represent the width with the letter W. And that's where we get this L and W here. Now, what you see, what I write down here, when you have a formula and two letters right next to each other like L and W, it means that we multiply L times W. And what I'm saying is that we have this L and W right here in our formula. Well, we know that when we have a formula like that, where two letters are right next to each other, two variables, then we get L times W. Now this is equal to our area, and a lot of times you're going to see area represented with the letter A. So today, let's shift gears a little bit, and let's talk about the area of a triangle. Now this is not much different than the area of a rectangle, and I do say you need to memorize the formula, but on the next slide here, I'm going to talk about how you don't actually really need to memorize a second formula for this if you understand where it comes from. So, before we get there, I do want to talk about this 1/2 that we see in the formula, because that's going to be um, a focus on the next slide. Now, you might not be as familiar with this, right? Because I've also written it where you can have the area, and we know that would be equal to the length times the width, and then we divide it by 2, right? Well, it turns out that this is actually the same exact thing as what we see here. Divided by 2 is the same thing as multiplying by 1/2. And let me show you that real quick. Let's take $10. If I split $10 into two halves, or in other words, I find out what half of $10 is, it's going to be 5, right? This will give us 10 over 2. 10 over 2 is the same thing as 5. 10 divided by 2, well, hopefully you know that. We know that's 5, right? Because 2 times 5 is 10. So we'll come back to that, but that is something that I want to make sure we understand. Because I know this might look a little different than maybe what you've been using. Right? It's the same thing, but this maybe looks a little stranger. So let me clear this. A triangle is really just half a rectangle. And I want you to really understand this here. Because if you understand that, that tells you why this 1/2 is here. if we take any rectangle, it doesn't matter what the length is, it doesn't matter what the width is. If I split this in half, I get two different triangles here. Now, on the slide, I split it the other way. And you see, I got a black triangle and I got a red triangle. So, let me show you this kind of the other way around. If we went ahead and found the area of this black triangle in the area of this red triangle here, right, 1/2 the length and the width, 1/2 the length and the width, well, we know that 1/2 plus this 1/2 here is going to give us the whole thing, right? We're taking the half of the length and the width. We're taking half of the length and the width. Well, if you take both halves, put them together, it gives you the whole entire rectangle. So, if you know the area of a rectangle, well, you always know that you can split any rectangle into two triangles. So you know that the area for the triangle is going to be 1/2 of that. So let's continue. Yep, sorry about that. So today, I'm only going to go through one example on this because it is very similar to yesterday's assignment. Um, if you remember yesterday, we were solving questions like this, where we had a whole green rectangle, then we subtracted a little hole in the middle, and we saw that this was equal to this area all the way around it. And so this whole thing would be shaded in over here. So if you took the whole outside rectangle, subtract the area of the hole, it gives you the area of everything that's left, everything around it. So that's what we did yesterday. Now, it's really the same thing with what we're going to do today. Except today, we're just going to work with a triangle. Two triangles. So, it's going to be the same idea as this. Like before, we had to find the area of the whole outside. Well, let's find the area of the whole outside triangle. Subtract the smaller hole-shaped or triangle-shaped hole. And we know that's going to be equal to the area of that orange region all the way around. So it's something like this. I'm not the best at drawing on the computer, but try my best. So that's our plan. Remember, I always said you should make a plan before you should try any question in math. Specifically word problems, but really any question at all. You need a plan to solve it. You need to make sure what you're doing makes sense. If it doesn't make sense, it's not going to be right. I know math can be confusing, but everything does make sense. There is a reason for everything. It's just whether you're going to practice and investigate enough to find out why it does make sense. Okay? Nobody's going to, 2 plus 2 is always 4. Nobody's going to tell you otherwise, and if they do, they're wrong, or they're doing some kind of trick. Okay, 2 plus 2 is always 4. Okay, so that's the beauty of math. Now, anyways, let's continue on with our plan here. And our plan was to find the area of this outside triangle. Well, we know to do that, we need to find 1/2 times length times the width. Well, the length is right here, width is right here. So we plug that in. We plug in L, or 16 for L. That's how we get this here. And then we plug in 12 for W. That's how we get this here. And now we're going to take this 1/2, and then we're going to multiply that by 16 and 12. Now, the trick to do that, to multiply this 1/2 times one of these numbers, is look for an even one. Okay? We know, in this case, they're both even, but let's take 1/2 times 16. We already said 1/2 times 16 was the same thing as 16 over 2, which is the same thing as 16 divided by 2, which is the same thing as 8. And we're going to use that 8 in just a second. Okay? So this, what I circled here, we're going to replace this with an 8. And that's how I got this 8 here. So now you just take 8 times the 12, and that gives you 96 square centimeters. And then you do the same thing with the area of the hole. You find the width, that's 11 centimeters. The length, oops, I just realized I switched these. This should actually be length here, this should be width. It's not going to change anything else up here, though. Yeah, in fact, I got it right up here. So we know that the length is equal to 11 centimeters. Okay? So we plug in this 11 for the L, and then we plug in an 8 for the W here. So now we do 1/2 times 11 times 8. Now, before I said multiply this 1/2 by an even number. And the reason for that is just it saves you an extra step. We know that even numbers can divide by 2 without a remainder, or without a fraction, right? 11 over 2, well, I mean, it's 5.5, but then you're starting to work with decimals, or you have to multiply with fractions, and it just makes it a little harder. Not much, but let's try and make it easier. So we do 1/2 times the 8, 1/2 times 8, 8 divided by 2, or 8 over 2 is the same thing as 8 divided by 2, which we know is 4. So this 1/2 and this 8, this here, I'm replacing with this 4 right here. We take the 11 times the 4, and that gives us 44 square centimeters. Now, there's one last step. We need to take this area and this area and subtract. And that's what we'll get here. So we find the area of the hole outside, subtracted the area of the hole. So the area of the hole outside was here. Area of the hole was here. Go ahead and find the difference. And that leaves you with the area of this outside orange region we see here, which is what they're looking for in the IXL. So this will give you 52 square centimeters. And that's the same steps for all the problems. You find the area of the outside, subtract the hole, leaves you with what's left. And the only difference with today is that we're working with triangles. We're not working with rectangles. So that's all I have for you. Good luck and have a good rest of your day. Thank you.